All right, everybody. So what we've got here is a model of a parallel circuit, something that you would find, say, in your home. Okay, now what we've got in place of different appliances or devices you would plug in, we have a light bulb. So for example, this light bulb might represent your light switch. When you come into your room and you turn the light on. This next one might represent, let's say, your TV in the same room, like if you have a gaming setup or something like that. And then this last one, let's just say it's like an Xbox or a PS5 or whatever. All right. Now, we know a lot about parallel circuits already. You guys do know that there are multiple pathways for electricity to flow. So this isn't an instance of everything either has to be on or off. All right. We can have different things on and off at different times. So one of the concerns with electricity in a home is something called a power surge. Right now, a power surge is simply um, a period or a time, and it's usually pretty brief, where there's a big burst of current that is much too strong for the circuit itself gets finds its way through the circuit, and that could cause a lot of damage to your devices. So in order to not prevent the surge, but to protect from the surge, we have a couple of things. One is a fuse. This is a traditional fuse used like earlier to mid 20th century. The idea here is that when too much current comes through, this is designed to fail. And the way it fails is there's a strip of metal in there, and when the current gets too high, that causes heat. It causes the connection to melt, and that stops the circuit immediately because the fuse is connected into the circuit in series. And as you all know, a series circuit, if something breaks, the whole thing breaks. So that's the point here. Now, this is more modern. What we use nowadays called a circuit breaker. Serves the exact same purpose, but this one is reusable. And we will talk about how this one functions because it's pretty amazing, the engineering that went behind that. All right. So what I'm going to do here is we're going to simulate like coming home from school or something, and I'm turning on turning on devices. So over here, this little light bulb is representing my fuse. So it's wired in series into this parallel circuit. So its job is to, in a way, monitor the current coming into the circuit. Each of these are rated to take a certain amount of current, and if you exceed that by too much, you can destroy them. You can burn them out or whatever. So this fuse here is, I think it's 0.3 amps is what it can support. So when we get past 3 amps of current, this fuse should fail, which should cut everything off. But what I want you to notice now, I'm going to come in, let's say you come home, you turn the light on. Okay, so we've got one light on. Now, over here, I know you can't see it on the camera most likely, but this bulb is dimly lit right now. That's just showing me that there's current moving through it at the moment. Okay, so you've turned your light on. Let's say the next thing you want to do is turn on the TV. So you come in and you turn the TV on. So perhaps now you can see that the light is lit up. I'm not sure how that's showing up on camera, but it's brighter than it was with just one. So now let's say you turn on your Xbox or your PS5 or whatever, and we see that this bulb is getting brighter. The fact that the bulb is getting brighter is just confirming what we already know about a parallel circuit. The more devices you add in a parallel circuit, the more current that circuit is demanding. So more current means our light bulb is getting brighter. Now, as long as we stay within our what we call load limit, which is the amount of current that a circuit can handle before it fails, then we'll be good to go. However, and a lot of us have had this experience before, if you're in, say, the restroom or something and you're blow drying your hair, and I use blow dryer because it's a really common appliance that draws a lot of current. So let's say that I'm going to replace this one here, and I'm going to take this heat lamp bulb, and this bulb is going to represent my hair dryer or any device that pulls a lot of current. So the idea here is that this is going to overload this circuit. So I want you to watch what happens with the fuse, and then subsequently the circuit itself once I install this. So this would be the equivalent of turning on a hair dryer or some other high current drawing device in a circuit that can't handle it. So watch the light bulb. It's going to be very quick. I'm sorry, watch the fuse, I mean. Let's see, almost, there we go. All right. So we see what happens. Immediately, when this makes contact, it draws a huge amount of current. Too much current for these other two bulbs to take. If we didn't have this fuse here, these would have been the things to fail. That would have been your TV, your Xbox, whatever. But the circuit itself is fine. This little fuse sacrificed itself for the circuit. And that's kind of the role of a fuse. Its job is to sacrifice itself for the rest of the circuit in order to save the devices that you have plugged into it. All right, so just a quick recap. We've got a parallel circuit here. We have, and again, just showing that we can turn different parts of the parallel circuit off and the others still work. And we have a fuse. The fuse's job is to fail. It is designed to fail when there's too much current moving through a circuit. All right, so I hope this is helpful for answering your questions from today's lab activity. Please watch this as many times as you need to, and also feel free to email me with any questions.